The remainder of the work for section 4.9 is to talk about particular solutions to our antiderivatives. When we've been writing the plus C, we've been writing the general solution to an antiderivative problem. Now what we're going to do is they're going to give us some initial conditions, some values at particular points of the functions, and that's going to allow us to find the particular solution. So when I first started about antiderivatives, I gave you like x squared, and then we had x squared plus 1, x squared plus 2, x squared plus a constant. Well, those are just a whole bunch of graphs of x squared. Well, what we're going to do is with the initial condition, it's going to let us find out exactly which one of those x squared curves would be the one they were talking about, or whichever curve for the family of functions that the plus c is giving to us that we are talking about. So what I'm going to do is I'm going to do some of the non-homework problems, just so that you can see how to do this. Our first step is going to be to find the antiderivative, and then we're going to substitute in the conditions that they give us to find out what C is. So the first one is problem 61. They tell me f of v is secant of v tangent of v, where big F of 0 is 2. So I need, going from little f to big F means I'm going to take the antiderivative. So I'm going to take the antiderivative of secant v tangent v dv, and that is equal to, well, what gives me secant tangent as its derivative? That would be secant of v plus c is equal to f, big F of v. Well, now what I'm going to do is I'm going to substitute the 0 in for v and put the 2 over here and solve for c. Well, secant is 1 over cosine, and cosine of 0 is 1. 1 over 1 is 1. So the secant of 0 is 1. So I get 2 is equal to 1 plus c. So c is equal to 1. I'm going to take that fact with this and write my final answer. F of v is equal to the secant of v plus 1. And now I have the particular solution. Reason why I chose 62 is there's a whole bunch of different ways to do 62. And what I'm going to do for 62 is I am going to divide everything by x squared. I'm also going to, first thing is I'm going to rewrite both of these as what they are in exponent form. So I'm going to rewrite that as x to the 1/2. I'm going to rewrite this as x to the negative 1/2. And then I'm going to divide everything by x squared, which is going to be subtracting 2 from each one of those exponents when I do the antiderivative. My recommendation is if you have square roots or cube roots, when you originally write down the problem, you write it in this form so that you don't have to do that extra step. So I want to find the antiderivative of 4. Subtract 2 from 1/2, that's going to be negative 3/2. Oops, I forgot x. So it's 4x to the negative 3/2. Subtract 2 from this, that would be negative 5/2 dx. So I'm going to do the antiderivative, add 1 to the exponent. So that's going to give me x to the 1/2, negative 1/2, times 4, divided by negative 1/2. Add 1 to the exponent. That was going to give me negative 3/2. Divide by the new exponent. Plus c. Now I'm going to simplify. 4 divided by negative 1/2 is the same thing as 4 times negative 2. So that's going to be negative 2. And I'm going to actually write this as the over the square root of x, because I'm now going to do some substitution. Dividing by negative 3/2 is the same thing as multiplying by negative 2/3. So I end up with a negative. So that would be 12 over 3, which is 4. Over x cubed in the square root. And I'm actually going to do the root cubed plus c. And I know the conditions that if I put a 1 in for my x's, I'm going to get 4 for my answer. So let me write this down. So I have negative 2 over the square root of 1 minus 4 plus c equals 1. Equals 4, sorry. That's negative 6. Add 6 to both sides. I get c equals 10. So the final answer is, sorry about the space, negative 2 x to the negative 1/2 minus 4 x to the negative 2/3, negative 3/2 plus 10. So these two problems, they gave me little f, and then the big F was the values they gave me. The next two problems, they say, hey, g prime, and then they give me g. They're the exact same type of problem. It says, hey, if I've got the derivative is equal to that, and the parent function value. Well, to go from the derivative to the parent function is you take the antiderivative of both sides. So it's the exact same thing that we were doing in problems. So I know that g of x is equal to add to the exponent, divide by the new exponent. 7 divided by 7 is 1. Add 1 to the exponent. Divide by the new exponent. Negative 4 divided by 4 is negative 1. And that becomes 12x. I know that when x is 1, I get 24. Oh, I forgot my plus c. That's why don't forget the plus c's, or you can make this a mess. So I have 1 to the 7th is 1. 1 to the 4th is 1 with a negative. 12 times 1 is 12. So this is 13 minus 1, which is 12. 12 minus 12 is 0. So I get c is equal to 0. So my final solution is x to the 7th minus x to the 4th plus 12x plus 0, which we are not going to write. This next problem, I'm going to take the antiderivative of both sides, but I need to get into a form that I can use. Well, I know cosine cubed divided by cosine squared is just cosine. So I can rewrite this as the square root of 2 cosine of theta. And I know 1 over cosine squared is secant squared theta. And I'm going to take the antiderivative of that with respect to theta. Well, the antiderivative of cosine is sine, so I'm going to end up with the square root of 2 sine theta. That's going to end up being y of x, y of theta. Antiderivative of secant squared is tangent plus c. And it says that when I put pi fourths in here and here, I get 3 for my answer. Well, I have the square root of 2. The sine of pi fourths is the square root of 2 over 2. Plus the tangent of pi fourths is 1. Square root of 2 times square root of 2 is 2. 2 over 2 is 1. 1 plus 1 is 2. 3 minus 2 is 1. So I get 1 equals c. Take these two facts and put them together. And I get y of theta is equal to the square root of 2 sine of theta plus tangent theta plus 1. So they're giving me initial values of my function so I can find particular solutions. The next three problems that I'm going to work through uses the facts that we were originally given in the first semester, where if I have a position function, we usually call it S of t. Then if I took the derivative of the position function with respect to time, I got a velocity function. And if I took the derivative again, which is taking the second derivative of position or the first derivative of velocity, I got an acceleration function. So if I have a velocity function and an initial condition, I can come up with a position function. If I have an acceleration function with some initial conditions, I can come up with a velocity function and possibly also the position function. So that's what the next three problems are going to have us do. Problem number 84 tells us to find the position function based when the velocity is equal to e to the negative 2t plus 4. And I did not assign this as homework because I haven't shown you again how to deal with that negative 2t. From the last homework exercises that I did, we ended up dividing by the derivative of that inside function, and that's what we're going to do now. I'm going to end up doing the same thing down here, dividing by that derivative of that inside function for the last problem. Again, you will not be responsible for these two on this group of homework, but next week you will be responsible. So what I want to do is I want to find the antiderivative. So my position function with respect to t is equal to the antiderivative of the velocity function with respect to t. Well, I am going to copy and divide by the inside derivative. Antiderivative of that would be plus 4t plus c. And it says when I put a 0 in for t, I get a 2 for my answer. So I know that 2 is equal to negative e to the 0 over 2 plus 4 times 0 plus c. E to the 0th is 1, so that's negative 1/2 plus 0. So I'm going to add 1/2 to both sides, and that's going to give me 5/2 is equal to c. So I now know my position function from that velocity function is going to be s sub t is equal to, I'm going to put the 4t in front so the negative sign is covered, 4t minus e to the 2t over 2 plus 5/2. So if you're given velocity and you want position, you're going to take the antiderivative once. The next one, I'm given acceleration, and it wants position function. So I'm going to take the antiderivative twice, and in between each step, I'm going to solve for the constants using the initial conditions they gave me. So it says acceleration of t is 4. Therefore, I know velocity of t is the antiderivative of 4 dt. The antiderivative of 4 dt would be 4t plus c. Well, when velocity is 0, I get negative 3. So I get negative 3 is equal to 4 times 0 plus c. That's 0, so I get c is equal to negative 3. So my final velocity function is equal to 4t minus 3. Well, I want the position function. So what I'm going to now do is I'm going to take the antiderivative of the velocity function. So s sub t is equal to the antiderivative of 4t minus 3 dt. Add 1 to the exponent. Divide by the new exponent. 4 divided by 2 is 2. So that's 2t squared minus 3t plus c. And it says when I put a 0 in for t, I get 2 for my answer. So I get 2 when that's 0 and that's 0, so my c is equal to 2. So my final position function is equal to 2t squared minus 3t plus 2. So again, from acceleration to position, you do the antiderivative twice, and in between each step, you're going to have to use the initial conditions they give you to solve for c. The next one, I have the acceleration is equal to 3 sine of 2t. So my velocity with respect to t is the antiderivative of this. Well, it's going to be 3 divided by the derivative of the inside function would be 2. Antiderivative of sine is negative cosine plus c. It says when I put a 0 in for t, I get 1 for v sub t. Cosine of 0 is 1. So I have 1 on the left is equal to negative 3 halves plus c. So that's 2 halves plus 3 halves is 5 halves. So c is 5 halves. So my v sub t final equation is negative 3 halves cosine t plus 5 halves. Now I'm going to take the antiderivative of v sub t to get s sub t. So s sub t is equal to, oops, I messed up a little bit. Forgot to put a 2 in here. Got to put the 2 in here. It did not affect this initial condition because 0 times 2 is 0. That's still the cosine of 0. So the antiderivative of cosine is sine, and divide by the derivative of the inside function. So I'm going to end up with negative 3/4 sine of t. Antiderivative of 5 halves is 5 halves t plus my constant. Says when I put a 0 in for t, I get 10 for s sub t. The sine, and again, I did it again, I forgot the 2t. The sine of 0 is 0, so that's 0. T is 0, so I get 10 equals c. So my final answer would be s sub t is equal to negative 3/4 sine of 2t plus 5 halves t plus 10. So one thing I want you to think about is if you know what your acceleration is, for example, a sub t is equal to negative 32 for negative 32 feet per second, or a sub t is equal to negative 9.8, and you write like a C1 for your first constant, and you can write a C2 for your second constant, you could actually come up with our vertical motion models. Okay? That's how we actually come up with the vertical motion models. We know what the acceleration is due to gravity, and you can work yourself backwards. And the two constants are going to be your initial velocity, and the other one would be your initial position. So that's how we can use this antiderivative process to come up with our vertical motion.